In question 1, we've got the sketch of the curve given here, y is x over 1 plus root x, and we've got the table of values for x between 1 and 3 with the corresponding values for y. And we need to use a trapezium rule with all the values of y to obtain an estimate for r, giving our answer to 3 decimal places. So the trapezium rule says that the area can be estimated by a half times the height of the trapezia, which is the difference between two consecutive values of x. So in our case, that's going to be 0.5. And then we've got the first and the last y values once. So 0.5 plus 1.0981. And all intermediate values twice. So 2 times 0.6742 plus 0.8284. plus 0.9686. Plugging everything carefully on the calculator gives an answer of 1.635125. Well, we've been given to give our answer to 3 decimal places. So my final answer for part A is going to be 1.635, and that's given to 3 dps. We are then told to explain how the trapezium rule can be used to give a better approximation for the area of R, and the answer is simply to use more trapezia so that we can more closely follow the curve, and therefore we minimize the error in the estimate obtained through the trapezium rule. In C, we need to use our answer to part A to deduce estimates for these two integrals, giving our answer to 3 decimal places. Well, we know from part A that the integral of x over 1 plus root x dx from 1 to 3 is approximately 1.635125. And in I, we need to estimate the integral from 1 up to 3 of 5x over 1 plus root x dx. Well, we know that the 5 can come out of the integral, so this is 5 times the integral from 1 to 3 of 5x over 1 plus root x dx. So this is simply 5 times our answer to part A, so 5 times 1.635125, which gives an answer of 8.17565. Well, we need to round this to 3 decimal places, so this is approximately 8.176. Please note that if you are using the rounded answer from part A, the 1.635, you would have obtained 5 times 1.635, which is 8.175, which is also acceptable. In II, we need to estimate the integral from 1 up to 3 of 6 plus x over 1 plus root x dx. So we've got the integral from 1 up to 3 of 6 plus x over 1 plus root x dx, which can be split as the integral of 6 from 1 up to 3 with respect to x, plus the integral from 1 up to 3 of x over 1 plus root x dx. Well, the first integral here can be calculated analytically, so this is giving me 6x from 1 up to 3, whereas the second integral is simply the answer to part A, which was found to be 1.635125. So this is giving me 6 times 3 minus 6 times 1. I'm substituting the limits, plus 1.635125, giving an answer of 13.635125. Rounded to 3 decimal places, it's giving me 13.635. In 2a, we need to obtain the binomial expansion of 4 plus 5x to the half up to the term in x squared, giving the value of k as a simplified fraction. So we need to start by factoring out the 4 so that we obtain a form of 1 plus or minus something. So 4 plus 5x to the half can be written as 4 to the half times 1 plus 5x over 4 to the power of a half. Remember that the 4 will inherit the power of a half, and because I factor out the 4, I also need to divide the 5x by 4. So I've got the right form to proceed with the binomial expansion. Well, 4 to the half is simply the square root of 4, which is 2. And then I've got 1 plus a half times 5x over 4 plus a half times minus a half over 2 factorial times 5x over 4 all squared plus dot dot dot. I only need to go up to the x squared term. I will simplify within the bracket, so it's 2 times 1 plus 5x over 8 minus 25x squared over 128 plus dot dot dot, which can be further expanded to give me 2 plus 5 over 4x minus 25x squared over 64 plus dot dot dot, and therefore we conclude that the constant k is minus 25 over 64. In BI, we are asked to use the expansion from part A with x being 1 over 10 to obtain an approximate value for root 2, giving our answer in the form p over q, where p and q are integers. Well, let me start by substituting x is 1 over 10 into the original expression. This means that the 4 plus 5x to the half becomes 4 plus 5 times 1 over 10 and all square root, and this is equal to 3 root 2 over 2. This simply means that if I substitute x is 1 over 10 into the expansion we just obtained, we will be obtaining an estimate for 3 root 2 over 2. So 3 root 2 over 2 is approximately 2 plus 5 over 4 times 1 over 10. So we're substituting x with the value of 1 over 10 minus 25 over 64 times 1 over 10 squared. We plug everything on the calculator, we get 543 over 256. This is an estimate for 3 root 2 over 2. So to obtain an estimate for root 2, I will multiply by 2 and divide by 3. So root 2 is approximately 2/3 of 543 over 256, which gives an answer of 181 over 128. Now I could use my calculator to check that my answer makes sense. So if I get my calculator and I take the value of 181 over 128 as shown here and I square it, I expect to get something close to 2 because I'm estimating the square root of 2. So I can see on the calculator 1.999572, etc. So this is a really good sign in favor of this being the correct answer. And then in II, we need to explain why substituting x is 1 over 10 leads to a valid approximation. Well, we know that if we put our expression in the form 1 plus or 1 minus something, then the expansion is valid for that something, its modulus being less than 1. So in our case, the expansion is valid for 5x over 4, its modulus being less than 1, which means that the modulus of x being less than 4 over 5, 0.8. So we can see that x is 1 over 10 is within the validity range, and therefore we have a valid approximation. In question 3, we've got this sequence of numbers a1, a2, a3 defined recursively. We start at 3, and then we use an plus 1 is an minus 3 over an minus 2 to generate the next term, and we need to evaluate the sum of the first 100 terms. Well, to do that, we need to identify the values for the first few terms. So we know that a1 is 3, so a2, the next term, is the previous minus 1 over the previous minus 2, which is equal to 3 minus 3 over 3 minus 2, which gives an answer of 0. The third term now is a2 minus 3 over a2 minus 2. Substituting a2 to be 0, we get 0 minus 3 over 0 minus 2. So this gives an answer of 3 over 2. And then for a4, it's going to be a3 minus 3 over a3 minus 2, which is 3 over 2 minus 3 over 3 over 2 minus 2, which gives an answer of 3, and we notice that this is a1. So since a4 is equal to a1, we are looking at a periodic sequence, and this repeats every 3 terms. So we say it's periodic with order 3. So every 3 terms form a pattern. Now I could have automated this on a calculator to see quickly that this will give me a periodic sequence with order 3. I will show you how. So going on the calculator, we start at A1 being 3, so I press 3 equals, so I've stored the 3 on my answer key, and then we evaluate ans minus 3 over ans minus 2. So each time I press the equal sign, I generate the next term, so I can already see that it's 0. I press it again, it's 1.5, the 3 over 2 we had here, and then it's 3, again 0, 1.5, 3, 0, 1.5. So this is the pattern here. So this is what I'm going to be using to evaluate the sum of the first 100 terms. So sum from r equals 1 up to 100 of AR simply means I've got 33 repetitions of the pattern, so 33 times 3 is 99, so that's the first 99 terms in this summation. So 33 times 3 plus 0 plus 3 over 2 plus the first term of a new pattern where the pattern starts at 3, so plus 3, which gives an answer of 303 over 2. In B, it says, hence find the sum from 1 up to 100 plus the sum from 1 up to 99. So the sum from 1 up to 100, we have already found this to be 303 over 2 through part A. And we need to consider how the sum of the first 99 terms can be found. So I have 303 over 2, which is the sum of the first 100 terms. And to find the sum of the first 99 terms, I can see that it's a multiple of 3, the 99. I've got 33 periods, 33 repetitions of the pattern. So 33 times 3 plus 0 plus 3 over 2. Plug this on the calculator, we'll get an answer of 300. In question 4, we are given the position vectors for points A, B, and C. And we are told that A, B, C, D is a parallelogram, and we need to find the position vector of point D. Well, it's really helpful for me to draw a quick sketch of a parallelogram. The vertices are A, B, C, D in a clockwise fashion. And we need to find the position vector of OD. That's the vector OD, which can be written as OC plus CD, which means that to go from O to D, I can go from O to C and then from C to D. Well, going from C to D is the same as going from B to A because we're looking at a parallelogram. So this can be written as OC plus BA, and the vector OC is 2, 10, 9, while to find the vector BA, I will simply do A minus B. So A is 1, 7, negative 2, and B is 4, 3, 3. And then we have 2 plus 1 minus 4 is negative 1. 10 plus 7 minus 3 is 14, and 9 minus 2 minus 3 is 4. So OD is minus 1, 14, 4. We are then told that the vector AX has the same direction as AB, and the length, the magnitude of AX is 10 root 2, and we need to find the position vector of point X. Well, let me start by finding AB, the vector AB is simply B minus A, so it's 4, 3, 3 minus 1, 7, negative 2, which gives me 3, negative 4, 5. I will also find the magnitude of AB, and we know that this can be found by applying Pythagoras in 3 dimensions. It's 3 squared plus negative 4 squared plus 5 squared and all square root. This gives an answer of 5 root 2. And since we are told that the vector AX has the same direction as the vector AB, this means that one is a multiple of the other. So we can say that the vector AX is lambda times the vector AB. If I take the magnitudes of both sides, we get that the magnitude of AX is lambda times the magnitude of AB. So we have that the magnitude of AX is given to be 10 root 2 is lambda times 5 root 2, and this leads to 2 being equal to lambda. So to find the vector ax, I will simply do 2 times the vector ab. The vector ab was found to be 3, negative 4, 5. So this leads to 6, negative 8, 10. In question 5, we've got this cubic f of x, and we are told that f of minus 6 is 0, and we need to show that a is 4. So we will simply start by evaluating f of negative 6, which is minus 6 cubed plus 8 times minus 6 squared, minus 8 times minus 6 plus 48. So this gives me minus 216 plus 36a plus 6a plus 48, which is equal to 42a minus 168. We have been given that the f of minus 6 is 0, so I will set 42a minus 168 to be 0, leading to 42a is 168, and therefore a turns out to be 4 as required. In II, we need to express f of x as a product of two algebraic factors. So, knowing that f of minus 6 is 0, this means that by the factor theorem x plus 6 is a factor. And one way to approach this is to do long division of f of x with x plus 6. So we've got x cubed, the value of a was 4, so that's plus 4x squared, minus 4x plus 48 to be divided by x plus 6. So we're doing long division here. Now x should be multiplied by x squared to give me x cubed. We're always trying to eliminate the highest order term found on the left. So x squared times x is x cubed, and x squared times 6 is 6x squared, and we subtract. We get minus 2x squared minus 4x plus 48. We now multiply by minus 2x to get minus 2x squared minus 12x. Again we subtract, and we get 8x plus 48. So we need a plus 8 here, leading to 8x plus 48, and the remainder of 0, of course, as expected. This means that we can write f of x as x minus 6 times x squared minus 2x plus 8. In part B, we are given this logarithmic equation, and we need to show that we can recover x cubed plus 4x squared minus 4x plus 48 is 0 from this logarithmic equation. So starting with what we are given, I will be applying the rules of logarithms. So 2 log of x plus 2 can be written as log of x plus 2 squared base 2 plus log x base 2 minus log of x minus 6 base 2 is equal to 3. We know that the sum of logarithms leads to the logarithm of the product, whereas when I've got subtraction, then I've got division within the logarithm. This means that the left-hand side can be written as the log of x plus 2 squared times x over x minus 6 base 2 being equal to 3, and I remove the logarithm by saying that x plus 2 squared times x over x minus 6 is equal to 2 cubed. Now, the left-hand side can be expanded into x squared plus 4x plus 4, whereas the 2 cubed is 8, and I'll multiply this by x minus 6. So we've got x cubed plus 4x squared plus 4x is equal to 8x minus 48. Collect everything on the left-hand side to give me x cubed plus 4x squared minus 4x plus 48 is 0 as required. And then in part C, we need to explain why this given logarithmic equation has no real roots. Well, we know that the argument of the log should always be positive, because the log of something negative or log of 0 is not defined. So we say x plus 2 to be greater than 0, and the x to be greater than 0, and x minus 6 to be greater than 0. So we need x to be greater than minus 2, and x to be greater than 0, and x to be greater than 6, which means that any solution in the given logarithmic equation should satisfy all three of those, and any solution for x should satisfy the strictest of the three, so it should satisfy x being greater than 6. We know that if x is greater than 6, then I satisfy this and this and this, so all three of them are being satisfied. We have already established through part B that this logarithmic equation leads to x plus 6 in the first bracket and x squared minus 2x plus 8 in the second bracket being equal to 0. So we get that x plus 6 is 0, or x squared minus 2x plus 8 is 0. So if x plus 6 is 0, then x is negative 6. It doesn't satisfy x being greater than 6, so we reject this, it's not valid. So we need to state this, reject, not valid. Whereas for the quadratic over here, I will be considering its discriminant, b squared minus 4ac. So in our case, it's minus 2 squared minus 4 times 1 times 8, which gives an answer of minus 28, which is less than 0. And therefore, we conclude no real solutions on this part. And therefore, because x minus 6 is not a valid solution and the quadratic here does not yield any real solutions, we conclude that the given logarithmic equation has no real solutions. In question 6, we've got the entrance to a road tunnel. It has a height of 5 meters, as you can see, and the width is 6 meters. And we are modeling the entrance through a quadratic curve BCA, shown here on the right. And we need to determine an equation for the curve BCA. Well, starting from the fact that the tunnel has a width of 6 meters, this means that point A should be at minus 3, 0, and point B should be at 3, 0, whereas C is at y is 5, because the height of the tunnel is given to be 5 meters. So starting from the cuts on the x-axis of minus 3 and 3, we can make an educated guess for the form of y. It will be x minus 3 times x plus 3. This is ensuring that we are cutting the horizontal axis at negative 3 and 3. However, there might be a constant, I'll call it k, outside. And I will actually use the third piece of information, that the y-intercept is 5, to determine the value of k. So when x is 0, we have that y is equal to 5. So I will substitute these two values to get that 5 is k times 0 minus 3, 0 plus 3, leading to 5 is minus 9k. So minus 5 over 9 is equal to k. And therefore, we've got the complete equation. Y is minus 5 over 9 times x minus 3, x plus 3. And this is defined between minus 3 and 3 because the tunnel lies entirely above the horizontal. So between minus 3 and 3, this is the equation for the quadratic curve. We're then told that there's a coach of height 4.1 meters and a width of 2.4 meters, and we need to determine whether it's possible for the coach to enter the tunnel. Well, if we quickly revisit the graph here, we can imagine the bus being treated as a rectangle. We're going to sit the bus exactly in the middle of the tunnel like this. So if it has a width of 2.4 meters, it means that this point here is 1.2 and this is minus 1.2. Well, the height is given to be 4.1, and I need to determine whether this point here will actually be touching or going above the tunnel itself. So we need to find the value of y when x is 1.2. So we have already established that y is minus 5 over 9 times x minus 3x plus 3. So I will substitute the value of x being 1.2. We get that y is minus 5 over 9 times 1.2 minus 3, 1.2 plus 3. This gives an answer of 4.2. And since 4.1 is less than 4.2, so the height of the bus is less than the height of the tunnel at the particular point, it is indeed possible for the coach to enter the tunnel. And then in part C, we need to suggest the reason why this model may not be suitable to determine whether or not the coach can pass through the tunnel. Well, one thing we could say is that the road may not be horizontal, and secondly, the cross-section of the tunnel may not be constant, so it might be the entrance, but it might not be the same throughout the tunnel, and therefore we might have the bus at some point not being able to go through. In question 7, we've got the curve here, y is 2e to the 2x minus x e to the 2x, and we need to determine using calculus, which means using integration, the exact area of R, giving our answer in the form pe to the 4 plus q, with p and q being rational constants to be found. Well, I will start by finding the cut on the x-axis, because I now be integrating from 0 up to this point here. So a cut on the x-axis means that y is 0, and therefore we've got 2e to the 2x minus x e to the 2x is 0. I will factor out the e to the 2x, so e to the 2x 2 minus x is 0. Well, e to the 2x is 0 can yield no real solution, so we say reject, not valid. And 2 minus x being 0 will give me that x is equal to 2. That's the boundary on the right hand side, and therefore we have that the region R is given by the integral from 0 to 2 of 2e to the 2x minus x e to the 2x dx. I will split this as the integral from 0 to 2 of 2e to the 2x dx minus the integral from 0 to 2 of x e to the 2x dx. The first one is a standard integral, whereas the second one is calling for integration by parts. I'm gonna put u to be x and v dash to be e to the 2x. U dash is 1, v, well, if I integrate e to the 2x, I get e to the 2x over 2, and therefore we've got the integral to be, the integral of 2e to the 2x is 2e to the 2x over 2 from 0 up to 2, whereas for the integration by parts, we've got the half x e to the 2x from 0 up to 2. This is the uv part, minus the integral from 0 up to 2 of e to the 2x over 2 dx. That's the u dash v, and all of this is in curly brackets. The 2 with the 2 here will cancel out, and if I substitute, I get e to the 4 minus e to the 0. And then for this part here, if I substitute 2, I get a half times 2e to the 4 minus 0 minus, well, the integral of e to the 2x over 2 will give me e to the 2x over 4, because I need to divide by 2 from 0 up to 2. So this is e to the 4 minus 1 minus, well, the half with the 2 will cancel out. I've got e to the 4 minus e to the 4 over 4 minus e to the 0 over 4. So we have evaluated all the integrals. We need to collect like terms together. So this is e to the 4 minus 1 minus brackets e to the 4 minus e to the 4 over 4 plus a quarter. We can see that the e to the 4 with this e to the 4 will cancel out. The minus e to the 4 over 4 will give me e to the 4 over 4, whereas the minus 1 minus a quarter will give me minus 5 over 4. And this matches exactly the form requested in the question. In question 8, we are told that 2,100 tons of wheat were harvested in 2017, and this is increasing by 1.2% per year, and we need to find the total mass from 2017 to 2030 inclusive, giving our answer to 3SF. Well, it makes sense to draw up a table with three headings: N, the year, and the wheat harvested in tons. Well, in 2017, which is the first term of the sequence, you had 2,100 tons. In 2018, which is N is 2, we had 2,100 times 1.012, which is the multiplying factor associated with an increase of 1.2%. Then in 2019, that's N is 3, is 2,100 times 1.012 squared. So keep going like that for 2030. We can see that this will be N14, because from 1 to go to 2017, I add 2016. Similarly, from 14 to add 2016, we have 2030. We see that this is a geometric sequence because consecutive terms appear in the same ratio. The first term of this geometric sequence is A being 2,100. The common ratio is 1.012, the multiplying factor, and I need to add 14 terms. So we need to evaluate S14, which is A 1 minus R to the N over 1 minus R, 1 minus 0.012. This is giving me 31,806.9948, which, correct to 3SF, is 31,800 tons. We need to include the units because it is a modeling question. We then have that the costs are $5.15 per ton for the first 2,000 tons of wheat and $6.45 per ton for every extra ton of wheat harvested. And we need to find the expected cost from 2017 to 2030. Well, we see that in the very first year we have exceeded the limit of 2,000. So we've got 14 years for which we will be paying 2,000 tons at $5.15. So 14 times 2,000, this is equal to 28,000 tons that will be charged, that will cost $5.15 per ton, and the remaining will be charged at the additional price of $6.45. So we have already found from part A 31,800 tons will be the total harvest over the 14 years. So 31,800 minus the 28,000, this gives 3,800 tons that will be charged at $6.45 per ton. So I can now proceed with some simple multiplications to find the total cost. So that's going to be given by 28,000 times 515 plus 3,800 times 645. Plug everything on the calculator to get 168,710. We've been asked to give our answer to the nearest 1,000 pounds. So this is giving me 169,000 pounds. In question 9, we've got the curve CY is 2x cubed plus 5 passing to the point 17, and we need to use differentiation from first principles to determine the gradient of the tangent at this point. Well, let's start by reminding ourselves that the derivative f dash of x is given by the limit as h tends to 0 of f of x plus h minus f of x over h. This is actually given in the formula booklet. So if I want to find the gradient at x is 1, so f dash of 1, this simply means I need to substitute x with 1 in the expression on the right hand side. Well, if f of x is 2x cubed plus 5, then we already have that f of 1 is 7, that's the y value, and f of 1 plus h can be found by substituting x with 1 plus h. So 2 times 1 plus h cubed plus 5. I will expand this to give me 2 brackets 1 plus 3h plus 3h squared plus h cubed, close brackets, plus 5, leading to 2 plus 6h plus 6h squared plus 2h cubed plus 5, which is 6h plus 6h squared plus 2h cubed plus 7. Well, let's consider f of 1 plus h minus f of 1 over h, which is going to be 6h plus 6h squared plus 2h cubed plus 7 minus 7, which is the f of 1, over h. We notice that the 7 with the 7 will cancel out, and if I divide throughout by the h, I get 6 plus 6h plus 2h squared, and therefore f dash of 1 is the limit as h tends to 0 of 6 plus 6h plus 2h squared, and the limit as h tends to 0 means I'm treating h to be practically 0, so these will be 0 and these will be 0, and this will simply give me an answer of 6. In question 10, we've got the function f of x defined to be 3x minus 5 over x plus 1 for x belonging to the reals not being equal to -1, and we need to find f inverse of x. Well, before we start, let's remind ourselves that x cannot be -1 because these will lead to division by 0 and therefore an undefined value for f of x. Now, to find the inverse, I will start by writing y to be 3x minus 5 over x plus 1. I will interchange x and y, so x is 3y minus 5 over y plus 1. And I will cross multiply x brackets y plus 1 is 3y minus 5. We're trying to make y the subject, so xy plus x is 3y minus 5, leading to x plus 5 is equal to 3y minus xy, and therefore x plus 5 is y brackets 3 minus x, so x plus 5 over 3 minus x is equal to y, and I can conclude that f inverse of x is equal to x plus 5 over 3 minus x. The answer is not complete. I also need to specify the domain of f inverse, and reminding myself that the domain of f inverse is the range of the original of f of x, I will actually sketch f of x to see the range and therefore deduce the domain for f inverse. So for f, we have that f of x is 3x minus 5 over x plus 1, with x attaining any value in the reals apart from -1. So for the horizontal asymptote, we need to consider the behavior of y as x goes to infinity. So as x goes to infinity, we can see that the -5 and the 1 are insignificant. So f of x will look like 3x over x, which is 3. So as x goes to infinity, y goes to 3, and therefore the horizontal asymptote is y is 3. Now this could also be done on the calculator without having to think of the limiting process on my own. So what I could do is substitute a really big value for x. So I just put lots of 9s here. I put the equal sign, and then I'm gonna do 3 minus 5 over my ans plus 1. So essentially I have substituted x with a really big value, and I have calculated the corresponding value of y. You can see the 2.9999. So the horizontal asymptote is at y is equal to 3. We also know that the vertical asymptote is at x is -1, and we can proceed with the cuts on the axis. When x is 0, we can see that y turns out to be -5, and when y is 0, we have 3x minus 5 over x plus 1 being equal to 0. So 3x minus 5 is 0, leading to x being 5 over 3. So plotting my pair of axes, we've got the vertical asymptote at x is -1, a horizontal asymptote at y is 3. we are cutting the x-axis at 5/3 and the y-axis at -5. So my graph looks something like this. We can see that the y values could be anything above 3 and anything below 3. In other words, the range of f of x would be all real numbers apart from 3. So f of x belongs to the reals f of x not equal to 3. And this is exactly the domain of f inverse. So going back to f inverse, we say x belongs to the reals x is not equal to 3. Remember that the examiner is expecting the domain every time you find an inverse, every time you find a function. In part B, we need to show that f of x, the composite function, is x plus a over x minus 1, where a is an integer to be found. So f of x is f of 3x minus 5 over x plus 1. And then I will input the 3x minus 5 over x plus 1 into f again. So these will give me 3 brackets 3x minus 5 over x plus 1 minus 5 over 3x minus 5 over x plus 1 plus 1. I will multiply everything by x plus 1 to get rid of the denominators within the fraction itself. So we get 3 brackets 3x minus 5 minus 5 brackets x plus 1 over 3x minus 5 plus x plus 1, leading to 9x minus 15 minus 5x minus 5 over 4x minus 4. So in the numerator, we've got 4x minus 20 over 4 brackets x minus 1, leading to 4 brackets x minus 5 over 4 brackets x minus 1. Obviously, the 4's will cancel out, and I'm left with x minus 5 over x minus 1, which is exactly of the form provided in the question, with a being equal to -5. In part C, we need to find the value of f of g of 2, where g of x is x squared minus 3x. Well, f of g of 2, I will start by finding g of 2. So it's f of 2 squared minus 3 times 2, which is f of -2. I will substitute x is -2 into f of x. So this is giving me 3 times -2 minus 5 over -2 plus 1, which is equal to 11. In part D, we're asked to find the range of g. Well, remember that g of x is a quadratic, x squared minus 3x, which can be factorized into x minus 3. The range is the values of y, and we've got the restriction here that x is between 0 and 5. I will start by sketching this. Well, it's a smiley parabola with cuts on the x-axis, obviously at 0 and 3. So it looks something like this. I will evaluate g of 0 and g of 5, the endpoints. So g of 0 is 0 and g of 5 is 5 times 5 minus 3, which gives me a value of 10. So we know that we are finishing at 5, 10, and we also pass through 0, 0. So this is 5, 10, and this is the origin. So these are the two endpoints. So my function is simply the part between these two. So it's this one here. And we also need to determine the y value for the minimum point over here. By symmetry, this should be the midpoint of the two cuts, so this should be 3 over 2. So g of 3 over 2 is 3 over 2 times 3 over 2 minus 3, which gives an answer of minus 9 over 4. So if I go down here and then to the left, this is gonna be minus 9 over 4, and we can see that g of x attains values between minus 9 over 4 up to and including 10. So we conclude that g of x belongs to the reals, and we've got minus 9 over 4 less than or equal to g of x less than or equal to 10. In part D, we need to explain why the function g does not have an inverse, and the answer is simply because g is not one-to-one. If you go back to the graph of g of x, you can see that it fails the horizontal line test because there are places where we cut at two places, and therefore it is not one-to-one. The only functions that do have an inverse are the one-to-one functions, and therefore g does not have an inverse. In question 11, we're given a sketch of curve C. We are told that we cross the x-axis, we cut at A and B as shown. Additionally, we've got that the derivative f dash of x is k minus 4x minus 3x squared, and we need to show that there's a point of inflection at x is minus 2 over 3. Well, let me remind you that the point of inflection is a point where f of x changes curvature, and we can determine curvature through the second derivative. So it makes sense to start by determining f dash dash of x, the second derivative with respect to x. This is simply minus 4 minus 6x, and then we set up a table of x and f dash dash of x. We've got a candidate at minus 2 over 3 as suggested by the question. We know that as a decimal, minus 2 over 3 is minus 0.666 recurring. So what I'll be doing is I'll be investigating the sign of f dash dash of x in the vicinity, in the neighborhood of minus 2 over 3. So if I go a bit to the left at minus 0.67 and a bit to the right at minus 0.65, I would like to see what f dash dash of x looks like. Well, at minus 2 over 3, if I substitute, I get exactly 0. At minus 0.67, I get 0.02, and at minus 0.65, I get minus 0.1. We know that if f dash dash of x is positive, then this means that the curve is concave, whereas if the second derivative is negative, then it's convex. So we can see there is a change of curvature, and therefore we conclude that there is a point of inflection at x is minus 2 over 3. In part B, we are given that the distance AB is 4 root 2, and we need to determine the integer value of k. We're starting from f dash of x being k minus 4x minus 3x squared. We can proceed with integration to find f of x. So we integrate k minus 4x minus 3x squared dx, leading to kx minus 4x squared over 2 minus 3x cubed over 3 plus c. And we have f of x is kx minus 2x squared minus x cubed plus c. We know that we pass through the origin, so f of 0 is 0. This means that c turns out to be 0, and therefore f of x is kx minus 2x squared minus x cubed. Well, a and b are cuts on the x-axis, so at a and b, we've got f of x is 0. So I could factor out the negative x, leaving me with x squared plus 2x minus k. So either x is 0, which is obviously the origin, or the interesting part is the x squared plus 2x minus k is equal to 0. And I could use the quadratic formula to obtain solutions for x. So x is minus b plus minus b squared minus 4ac square root over 2a. So this leads to x is minus 2 plus minus 4 plus 4k in a square root, and all of it over 2. So obviously the positive solution is for b and the negative solution is for a. I could write here that x of a is minus 2 minus the square root of 4 plus 4k and all of it over 2, whereas the solution for B is minus 2 plus the square root of 4 plus 4k over 2. The difference between the two is xb minus xa, which is minus 2 plus the square root of 4 plus 4k square root over 2 minus 2 minus the square root of 4 plus 4k over 2. The minus 2 with the minus 2 will cancel out because I am deducting one from the other, whereas the other two will add up into 4 plus 4k and all square root. So this, I've been told, is equal to 4 root 2. I could get rid of the square roots by squaring everything. So 4 plus 4k is equal to 4 root 2 all squared. So 4 plus 4k is equal to 32. 4k is equal to 28, and therefore we conclude that k is 7. In question 12, we are asked to show that the integral of sine 2 theta over 1 plus cos theta from 0 to pi over 2 is 2 minus 2 ln 2. We haven't been specified the method to use. I'm thinking of maybe using trigonometric identities to rewrite the given integral in terms of theta, and then I will possibly choose a substitution, even though there are other approaches that we could also adopt. So the integral from 0 to pi over 2 of sine 2 theta over 1 plus cos theta d theta. Well, I see that in the numerator we've got the double angle for sine, so it's 2 sine theta cos theta over 1 plus cos theta d theta. So I'm thinking of letting u be 1 plus cos theta because that's the denominator. Then du is going to be minus sine theta d theta, which means that minus du is sine theta d theta. The reason is that sine theta d theta here appears in the given integral, so that's going to be just negative du. The 1 plus cos theta will simply be my u, and the cos theta that appears here will be u minus 1. So I can replace everything with u terms. I also need to take care of the limits. So when theta is 0, we get that u is 1 plus cos 0, which turns out to be 2. Whereas when theta is pi over 2, we get u is 1 plus cos of pi over 2, which is 1. And therefore the integral from 0 to pi over 2 of sine 2 theta over 1 plus cos theta d theta can be written entirely in terms of u as the integral from 2 to 1 of 2 brackets u minus 1, that's the cos theta, times minus du, all of it over u. Well, the negative sign in the du can be consumed into reversing the limits of the integral. So I'll be integrating from 1 up to 2 of 2u minus 2 over u du. This can be written as the integral from 1 to 2 of 2 minus 2 over u du, which leads to 2u minus 2 ln u from 1 to 2. I will substitute the limits. The upper limit is 2, so this is 2 times 2 minus 2 ln 2. And then I will deduct the lower limit, 2 times 1 minus 2 ln of 1. We know that ln of 1 is 0, so that's 0. And I've got 4 minus 2 ln 2 minus 2, which leads to 2 minus 2 ln 2 as required. In 13, we are asked to express 2 sine theta minus 1.5 cos theta in the form r sine theta minus alpha. We need to state the value of r and give the value of alpha to 4 decimal places. So we've got 2 sine theta minus 1.5 cos theta to be written as r sine of theta minus alpha. Well, I'll be using the compound formula for sine A plus B. This is r sine theta cos alpha minus r cos theta sine of alpha, and I will be equating the cos theta terms and the sine theta terms. So 2 sine theta should be equal to r sine theta cos alpha, and 1.5 cos theta should be equal to r cos theta sine alpha. Notice that the signs, the negative sign here, will cancel out. So we've got 2 is equal to r cos alpha, and 1.5 is equal to r sine alpha. This means I can write 2 over r to be cos alpha, and 1.5 over r to be sine alpha. And I can proceed by drawing a right angle triangle. So there it is. This is alpha. So the cosine is adjacent over hypotenuse, and the sine is opposite over hypotenuse. So using Pythagoras, we can see that r is 1.5 squared plus 2 squared square root, which gives an answer of 2.5, and tan alpha is 1.5 over 2, which leads to alpha being 0.6435 to 4 decimal places. So to conclude, we have 2 sine theta minus 1.5 cos theta is equal to 2.5 sine of theta minus 0.6435. Now, Tom models the depth of water d meters at the harbor on the 18th of October of 2017 by this formula, and we need to find the depth of water at the beginning of the 18th of October. So we've got that t is 0, so when t is 0, I will substitute in the given formula. So it's 6 plus 2 sine of 0 minus 1.5 cos of 0, which gives an answer of 4.5 meters. Remember, you need to provide units because this is a modeling question. And in part C, we need to find the maximum depth of water. Now, there is a clear connection with part A. In part A, we have expressed 2 sine theta minus 1.5 cos theta as a single sine. So we've got the same structure here, the 2 sine 4 pi t over 25 minus 1.5 cos 4 pi t over 25. So the 4 pi t over 25 is essentially my theta. So I could start by writing d to be 6 plus 2.5 sine of 4 pi t over 25 minus 0.6435. Well, we're looking for the maximum depth. We know that sine of any angle varies between plus minus 1. So 2.5 sine will vary between plus minus 2.5. So to find the maximum depth, I'll call it d max. This will simply be 6 plus 2.5, which is of course 8.5 meters. In D, we need to find the time in the afternoon when the maximum depth of water occurs, giving our answer to the nearest minute. Well, we have already seen from part C that the maximum will be obtained when this is equal to 1. So I will start by setting sine of 4 pi t over 25 minus 0.6435 to be equal to 1. I will do shift sine of 1. I get the PV to be pi over 2. And therefore, we've got 4 pi t over 25 minus 0.6435 to be pi over 2 plus 2 pi k. I will be trying to isolate t. So the first step is to write 4 pi t over 25 is pi over 2 plus 0.6435 plus 2 pi k, and then t is 25 over 4 pi brackets pi over 2 plus 0.6435 plus 2 pi k. Remember, we are trying to find the first time in the afternoon, so I could actually use my calculator to generate all solutions and then just pick out the one that is in the afternoon. So I go on my calculator, I press mode, I choose table, and my f of x will be exactly what we have here for t. So it's going to be 25 over 4 pi, and then open brackets, I've got pi over 2 plus 0.6435 plus 2 pi x, and I will let x go from 0 up to 3 maybe, and we'll see what kind of values we get. I press the equal sign, g of x, I'll leave it empty. I will start at 0, I will stop at 3, and I will be stepping every one. So all of these solutions for f of x are valid times, and I want to pick the one that's in the afternoon. If I just click on the first one here, we can see that it's at 4, 24, 18 seconds, and so on. That's in the morning. So I go to the second one here, and I see 1600 hours, 54 minutes, and 19 seconds. So I can immediately deduce that the time I'm after is 16:54 in the afternoon. So immediately I've got 16:54. We then have that Tom's model is supported by measurements of D taken at regular intervals on the 18th October of 2017. So we know that Tom's model is a valid one. And Jolene attempts to use a similar model for the next day, the 19th of October. So she comes up with this formula here. By considering the depth of water at the beginning of 19th October 2017 for both models, explain why Jolene's model is not correct. So we know that for Jolene's model, we need to put x is 0. So when x is 0, we have that h is 6 plus 2 sine of 0 minus 1.5 cos 0, which turns out to be 4.5 meters. This is the depth predicted by Jolene's model. Whereas if I go to Tom's model and I put t is 24, then I would be expecting to get the same, or at least a very similar result, because these times coincide. It's the midnight of the previous day and the starting of the next day. So when t is 24, d is 6 plus 2 sine of 4 pi times 24 over 25. We're substituting t with 24, minus 1.5 cos of 4 pi times 24 over 25. This gives an answer of 3.72 meters. And since the two do not match, we say since 4.5 meters is not equal to 3.72 meters, Jolene's model is not correct. And it says, hence find a suitable model for h in terms of x. We need to propose a model that will give me a height of 3.72 meters when I substitute x is 0. So what I could do is leave the structure with the sines and the cosines. So I will leave the 2 sine 4 pi x over 25 minus 1.5 cos 4 pi x over 25. And I want to make sure that when I plug in x is 0, I get 3.72. Well, when I put x is 0, this is giving me overall 0 minus 1.5. I want this to be 3.72. So maybe I will put a constant here. And the constant is obviously the 3.72 plus 1.5, which is 5.22. So h is 5.22 plus 2 sine 4 pi x over 25 minus 1.5 cos 4 pi x over 25. And this is valid for x between 0 and 24. In 14, we've got the sketch of the curve C defined parametrically as x is 4 cos of t plus pi over 6 and y is 2 sine t. and we need to show that the Cartesian equation of C can be written in this form. Well, I will start by considering x, which is 4 cos of t plus pi over 6. I will use the compound formula for cos A plus B to expand this. It's 4 cos t cos of pi over 6 minus 4 sine t sine of pi over 6. Well, we've got that cos of pi over 6 is root 3 over 2, so this is 4 root 3 over 2 times cos t, and the sine of pi over 6 is a half, so 4 times a half sine t, leading to x being 2 root 3 cos t minus 2 sine t. We notice that since y is 2 sine t, it makes sense to consider x plus y. So this is 2 root 3 cos t minus 2 sine t plus 2 sine t, which simplifies to 2 root 3 cos t. And therefore, I've got an expression for cos t, I've got an expression for sine t through y. So we would consider now the identity cos squared plus sine squared is 1. So cos squared t plus sine squared t is equal to 1. We've got that cos is x plus y over 2 root 3. So x plus y over 2 root 3 all squared. And sine t is y over 2. So y over 2 all squared is equal to 1. Leading to x plus y all squared over 12, which is the 2 root 3 squared, plus y squared over 4 is equal to 1. I will multiply throughout by 12 to arrive at x plus y squared plus 3y squared is equal to 12, which matches the form given in the question, with the constant a being equal to 3 and the constant b being equal to 12.